Welcome back to Zurich and PASC 24, where we are reporting on the first mini symposium today. Joining me, I have Will Sawyer from CSCS, and you organized a symposium on energy efficiency and the CO2 impact of climate modeling.
Yes, thanks for inviting me. I had organized the mini symposium together with my co-chair, Jan Friedrich Engels, who actually originally made the suggestion in order to talk about tools related to energy consumption, power consumption of models, and how we report those, for example, to users, right? To give them more information about their impact of their models.
So this course is exceptionally timely, right? On the one hand, we're making tremendous advances on these climate research, and yet, as computational people, while we do so, we end up emitting more CO2 to do exactly that.
Indeed.
So what was the main outcome of the symposium? What did you learn?
So, I think we were able to propagate some of these tools and tell people more about how we can report on their impact. The mini symposium actually went a little bit farther than that and talked about the carbon footprint of certain applications, in particular the ICON model. And I presented some initial results on the amount of the tons of CO2 equivalent, which would be accounted to a model such as ICON, which is not small because we run these simulations at very, very high resolution.
So will modern methods such as machine learning also help this in any way? Are we able to do the same predictions but with less CO2?
Right, great question. There is a lot of work in our field, climate modeling, to insert machine learning components into existing models that can cause them to run a lot faster. On the other hand, you can't forget the amount of energy and carbon which goes into training these models. And when you take that into account, it's not clear whether overall that they're more efficient and have a less of a carbon footprint.
But on the other hand, I would assume, given the say one type of model, an upgrade such as the new Alps computer is going to be orders of magnitude more efficient than Pitt-Stein, right?
Not orders of magnitude. In fact, we did tests on exactly this. Obviously, these GPUs are very, very powerful in the new Alps machine. However, they draw a lot more power, right? So when you make the final analysis, the improvement is roughly, for our application, is roughly a factor of 3 improvement in energy
so 3 is important, but it sounds like we have more work to do then there.
We have more work to do, and it's not only the electricity consumption, it's also other things which we do in our business, professional lives. For example, flying, for example, commuting, and things like this.
I was going to ask that. When we come back a year here, we all go back energized from these meetings. Over the next year, what is the important I and everyone here should do, both as humans in general, but with a particular interest in computing? How can we help?
How can we help? It's a great question. So one we analyze the carbon footprint of CSCS. The largest contribution is obviously the electricity used for computing. However, air travel is really considerable. And on the same scale as the electricity we consume. And given that, I think we should be a little bit more cautious about where we travel to. Can we participate virtually at conferences? Can we combine multiple visits into one trip? These are all things which I think individuals like you and me can do to reduce the carbon footprint.
And also make sure that even when we are present, make sure that we share some things online,
Absolutely.
such as these things, to those of you who can't be.
Exactly.
Again, thank you so much, Will, and thanks for joining us. Have a great conference.
Thank you very much, Eric.